Secondary succession in Point Pleasant Park following Hurricane Juan.
Let's give some background. Succession is how organisms and their environment respond after a large disruption to the habitat. There are two types of succession. Primary succession is when ecosystems must rebuild themselves due to the introduction of a new foundation, and secondary succession is when an ecosystem must rebuild itself after some sort of major destruction, such as a natural disaster. Climax community is when a community can reach a stable equilibrium through the mechanism of succession. Point Pleasant Park is an urban park located in Halifax, Nova Scotia, and is known as an Acadian forest. For the Mi'kmaq community, the park is a spiritual gathering place where they would gather yearly for the week after the first full moon of the spring season. On September 29, 2003, Atlantic Canada was hit by Hurricane Juan. This was a Category 2 storm that destroyed 70% or around 70,000 trees in Point Pleasant Park. Hurricane Juan disrupted roots of trees and other plants and had the biggest impact on canopy trees. This phenomenon entered Point Pleasant Park into a state of secondary succession. Past research collected by Maria Turchin showcases the role of succession in Point Pleasant Park from after the hurricane to 2015. Overall, these results showcase that species richness and evenness had increased over time and was founded upon the growth of shade-intolerant species. This study does not give any further information for years after 2015 and does not directly address how the park is moving towards climax community after the hurricane. Our study will be investigating succession in Point Pleasant Park since Hurricane Juan using data collected between 2004 and 2023. We want to begin to answer how the overall community has changed, how the dominant species have shifted over time, and how succession has impacted the species' richness and evenness. We also want to investigate how these three topics are affected as the park moves towards climax community. Our null hypotheses for overall density, diversity, growth, dominant species density, richness, and evenness all state that there is no significant relationship between time since Hurricane Juan and the identified variable. Our current prediction states that there is a relationship between time and these variables, and that overall succession since the hurricane will produce greater density, diversity, growth, and more.
Now let's talk about our methods. 6 20-meter by 20-meter sites shown in Figure 3A were chosen in the regions of Point Pleasant Park in Halifax, Nova Scotia, Canada that sustained the greatest damage to forest structure from Hurricane Juan. This gave us the best representation of the hurricane's impact. All data was collected by introductory ecology students of Dalhousie University. Each year following Hurricane Juan in 2003, all living trees within the 6 sites with a diameter at breast height of equal to or greater than 2.5 centimeters were identified and measured in diameter at a standard 4.5 foot height. This gave us information on density and species composition within sites. Tree density was calculated as the number of trees per 400 square meters. Diameter at breast height measurements were made using a measuring tape following standard diameter at breast height procedures. Trees were identified using Donnelly's 1960 identification of Nova Scotia woody plants. Data was not collected in 2005 due to Hurricane Ophelia, 2007 due to Hurricane Noel, 2016 due to Hurricane Matthew, and 2020 due to the COVID-19 pandemic. These measurements and identifications allowed us to calculate total density, mean diameter at breast height, Shannon diversity, species richness, red maple and red spruce density, and evenness. The data was plotted in scatter plots displaying the change in a given metric over time in years, and analyzed using regression analysis to test for significant positive or negative correlation between the given metric and time. This gave us the best understanding of how the metrics changed over time since Hurricane Juan. Now for the results and discussion. How has the overall forest community changed over time following Hurricane Juan? Looking at Figure 4, we can see that total tree density increased from less than 25 trees per 400 square meters in 2004 to an average of 150 trees per 400 meters squared in 2023. The goal of this portion of the experiment was to observe secondary succession at Point Pleasant Park following Hurricane Juan by determining if there was significant correlation between total density and time. Total density was measured in Point Pleasant Park each year following Hurricane Juan in 2003 and plotted against time in Figure 4. Regression analysis suggested strong positive correlation between time and total density. Based on these results, we reject the null hypothesis and infer that total density increased with time following Hurricane Juan. Looking at Figure 5, we can see that Shannon diversity in Point Pleasant Park increased from an average of roughly 0.5 in 2004 to an average of roughly 1.75 in 2023. The goal of this portion of the experiment was to observe secondary succession in Point Pleasant Park following Hurricane Juan by determining if there was a significant correlation between Shannon diversity and time. Shannon diversity was measured in Point Pleasant Park each year following Hurricane Juan in 2003 and plotted against time in Figure 5. Regression analysis suggested strong positive correlation between time and Shannon diversity. Based on these results, we reject the null hypothesis and infer that Shannon diversity increased with time following Hurricane Juan. Now, what caused these changes? By destroying the majority of the forest canopy, Hurricane Juan drastically increased the available territory for new tree growth. Early successional tree species quickly occupied the new open territory and multiplied until the space was filled, leading to an increase in total forest density. Noseworthy explains that this is characteristic of successional Acadian forests. Additionally, with the dominant forest canopy no longer present, access to sun, water, and nutrients was no longer restricted for species that would normally be outcompeted, meaning more species are able to survive and Shannon diversity increases. What will the climax community look like? As the forest progresses towards its climax community, I expect the total density and Shannon diversity to decline. As shown in Figure 8, as Acadian forests mature and a canopy of mature trees begins to form, competition limits access of certain species to resources such as water, nutrients, and sunlight. Certain species will not be able to compete with others, and the populations of these species will shrink and presumably disappear. I expect this to not only decrease the number of trees and therefore the density, but additionally the number of tree species and the Shannon diversity.
The second question we are trying to answer is how has the density of the dominant species in Point Pleasant Park in 2004 as well as the dominant species in 2023 in the park changed over time? Red spruce, or Acacia rubens, was the dominant species in the park in 2004. A regression analysis was performed to explore the relationship between red spruce density in the park and time since Hurricane Juan. There was a weak positive relationship between red spruce density and time. Excluding some obvious outliers, the red spruce density increased from an average of 3.25 red spruce per 400 meters squared in 2004 to an average of 6.75 red spruce per 400 meters squared in 2023. While this is a doubling in density of red spruce does not consistently surpass 15 individuals per 400 meters squared at any given year. The null hypothesis is rejected from this data. However, the relationship between the two variables is not strong enough to estimate red spruce density from the determined regression equation. Red maple, or Acer rubrum, was the dominant species in 2023. Another regression analysis was performed to explore the relationship between red maple density in the park and time since Hurricane Juan. There was a weak positive relationship between red maple density and time. There is a greater increase in red maple density over time than there was with red spruce. The average density of red maple in 2004 was 0 individuals per 400 meters squared, and the average density in 2023 was 35.5. This is an increase of nearly 40 times. The null hypothesis is still rejected. However, the relationship between the variables is not strong enough to accurately determine red maple density from the determined regression equation. Why is this so? Red spruce is shade tolerant, meaning it thrives in environments with a closed canopy. It takes anywhere between 350 to 450 years for red spruce to reach its maximum maturity, which is quite a long growth time. Red spruce was dominating in the park before the hurricane hit. It is possible that red spruce was only dominant in 2004 because of this strong foundation. The open canopy that Hurricane Juan produced would have made it extremely difficult for red spruce to establish new growth, which aligns with our data. Red maple is a shade-intolerant species, meaning that it does not thrive in low light levels. Red maple is known to grow much faster than red spruce. According to Burley, after Hurricane Juan, red maple was found in parts of the park that were destroyed. This is most likely because red maple was able to tolerate the harsh sunlight of the open canopy areas produced by Hurricane Juan. Due to its long growth rate, it can be predicted that red spruce numbers will continue to increase as Point Pleasant Park nears climax community. As the red maple continues to grow, it is possible that the shade that they produce will also allow for further growth of red spruce. The red maple will begin to decline earlier than the red spruce due to their shorter lifespan.
The final topic to discuss is how species richness and pilose evenness has changed over time and how they may react as the forest moves towards its climax community. Here in Figure 14, we can see the linear regression analysis comparing species richness and time, which indicates that there is a positive correlation between time after Hurricane Juan and species richness in Point Pleasant Park. When comparing the species richness in Point Pleasant Park from post-hurricane to more recent years, the approximate number of unique species recorded has increased by six-fold. Due to the positive correlation of the variables and a statistically significant p-value, we must reject the null hypothesis. Therefore, there is a significant correlation between the species richness in Point Pleasant Park and the time after the hurricane. One may predict, based on the trends in Figure 14, that species richness will continue to increase over time. However, as the forest reaches its climax community, the species richness may become fixed as there are only so many native plant species capable of living in Point Pleasant Park, and the ones able to adapt early generally become more dominant, preventing new growth. That being said, there is always the potential of human interference increasing or decreasing species richness. For the regression analysis of Pailou's evenness, an insignificant p-value of 0.15 was obtained, indicating that the null hypothesis must fail to be rejected and that there is no significant correlation between time after Hurricane Juan and species evenness in Point Pleasant Park. Since the species richness has been steadily increasing since the hurricane, this has affected the efficiency of recording the evenness over time. Each new species introduced to Point Pleasant Park is another variable when measuring the evenness, and analyzing the evenness in a relatively new ecosystem is a source of the lack of trend in the data. As the forest moves closer to its climax community, one may predict that Pailou's evenness may decrease, as there will be a high species richness with the potential of some species being dominant, showing their prevalence. In conclusion, based on the data trends analyzed and the theory of secondary succession, we predict that the Acadian forest in Point Pleasant Park is in mid-stages of succession. It appears that most species are now established in the area and that the introduction of new prospering species may become more and more rare, therefore allowing for the growth of the currently situated populations. One factor that may affect the succession of urban parks like Point Pleasant Park are local development in the area causing disturbance in the environment and introducing pollutants affecting the park's ecosystem. An additional factor affecting the succession of urban parks is human traffic. Any traffic off the set path causes damage to the surrounding ecosystem, and ensuring proper waste management is in play is another crucial aspect to consider when it comes to human involvement. Caring for urban parks not only benefits our own well-being, but is also a global conservation effort. A crucial perspective to keep in play is the knowledge and practices of our native ancestors. For the forest to prosper and reach its climax community, these traditions and two-eyed seeing should be incorporated, allowing for a deeper connection to be made with the land and to host urban parks in our own city.
We would like to thank Allison Schmidt and Ned Murley, the previous Biology 2060 students who collected our data, our peer reviewers, and Dalhousie University.
Now for a brief question period. As shown in Figure 16, both the frequency and severity of storms and floods have increased worldwide since 1964. Being directly on the coast, Point Pleasant Park is indeed very exposed to conditions having no structures or landscapes to shield winds and water. If natural disasters do continue to increase in frequency and severity, another event similar to Hurricane Juan would not be unexpected. This would once again reduce the density, diversity, and richness of the forest and could mean the forest never does stabilize. Depending on the frequency and severity of natural disasters, certain tree species may become locally extinct, which could drastically affect the park's ecosystem. If it were ever to reach stability, certain species may no longer be present if they are not able to survive in the changing conditions.
Some implications of tree uprooting on soil structure are that when a tree is uprooted, it creates a well, and the soil remains attached to the root system of the fallen tree. When the tree starts to decompose, the roots release the attached soil and form a mound within the well. Depending on the tree size, a significant amount of bedrock can be uprooted and broken down into loose soil. The mounds can be compared to tilled soil, which is good for new growth, however the wells are often prone to flooding. The decay of plant matter, in this case being the fallen trees, is a significant contributor to humus and organic soil. This helps increase nutrients and promotes the growth of new life in the area. When considering how humans can improve soil quality, there are many things we can do. Landscaping and min-maxing certain nutrients can be beneficial for organic growth. However, an excellent solution would also be to do nothing and let Mother Nature play its role in creating new life.
Data from the government of Nova Scotia showcases that natural disasters will become more frequent, intense, and widespread. It is absolutely our responsibility to care for forests that are affected by storms caused by climate change. Forests are essential habitats for us, but also for the continued life of land. The Mi'kmaq peoples exemplify this in their understanding that people are not distinct from the land, but rather the land is an all-encompassing being of everything organisms need. We can't reverse our past, but we can be proactive in our actions to avoid further damage. Restoration is the key to this proactivity. Cleanup after a storm, planting of new flora, data collection, and monitoring are all examples of this. There is only so much that we can do to interfere in the recovery of natural habitats. The forest must be able to thrive on its own. Direct human interference can be limited once climax community has been achieved. However, this does not mean that monitoring or troubleshooting should ever let up. Here are references. Thank you for listening.